Coming up on This Week in Enterprise Tech, is Cisco feeding the trolls? Is Comcast invading your Wi-Fi space? Oh, and yeah, DNSSEC. Twiet on the set.
Netcasts you love.
From people you trust. This is Twit.
Bandwidth for This Week in Enterprise Tech is provided by CacheFly at CacheFly.com.
This is Twiet. This Week in Enterprise Tech, episode 79, recorded February 7th, 2014, or February 10th, 2014. Stop feeding the pigeons. This Week in Enterprise Tech is brought to you by Jira, an Atlassian product. Jira is the project management solution for teams planning, building, and launching great products. To learn more about Jira and try it free for 30 days, visit Atlassian.com/Twiet. And by RingCentral. The cloud-based phone system we use just got better with the launch of Meetings, the full-service video conference feature. Zero startup costs, and RingCentral starts at under $25 per month per user. Try it now with a 30-day risk-free trial and buy one desk phone and get a second phone free, up to 20 phones. Call 800-543-9980 or visit ringcentral.com and use our promo code TWIT. Welcome to Twiet, This Week in Enterprise Tech. It's the show dedicated to the enterprise professional, the IT pro, and the geek who just wants to know how the world is connected. I'm your host, Father Robert Balacer, the digital Jesuit, your guide to all things in the enterprise. But as always, I'm not alone. I'm joined by an all-star cast of characters, starting with my good friend, Mr. Brian Chi, the geek in paradise. Brian, how are you on this, well, over here in San Francisco, rainy Friday?
Well, it's rainy in Honolulu. In fact, as I was driving into work today on the other side of the poly, I saw a landslide where a whole bunch of trees had fallen down into the roadway, and the city and county were trying to bulldoze them out of the way. Fun and games on the freeway.
That's kind of a problem in Hawaii. I mean, there's really only that loop around the island, right?
Well, you know, there's a couple ways of getting into town from where I live in Kaneohe, but it's been raining an awful lot. I think we're up to about 10 inches this month.
Whoa. Okay. Well, we're going to have to keep a watch on that. Now, someone who comes from an area where it never, ever rains is a person you may have seen on the Twit TV network, Mr. Lou Maresca from Microsoft. Lou, I forgot, where do you live again?
Seattle. It's actually pretty cool here today. It's pretty warm and pretty cool.
Well, I mean, Seattle has that reputation.
Rain there,
never raining.
It's sunny today. It was sunny today.
Okay. Now, you've seen Lou. He's been a guest on This Week in Enterprise Tech. He's been a guest on Coding 101. Lou, you're kind of taking over the Twit TV network. I don't know if I'm comfortable with that.
Slowly but surely.
Slowly but surely. Well, what did the two of you say? Shall we jump into some Enterprise Bites?
Let's do it.
Let's do it. All right. The first one comes to us from Ars Technica. This is a little reminder. It's an update. We first heard about this story last year, around June or so, that Comcast was going to start replacing their home routers, you know, the ones that combine the cable modem with the router and the Wi-Fi hotspot, with units that included a guest Wi-Fi network, an SSID for the Xfinity wireless service. Now, the problem with this is that they haven't really been telling their customers that they're doing this. I mean, they made a general announcement, but there are a lot of reports of customers who say they were surprised when they found this extra wireless network in their house. They weren't really sure what it was doing there. Now, Comcast says, well, we do offer an opt-out, but that's the problem. It's an opt-out program. They, by default, turn the thing on, and it's not like you can jump into the web interface and just turn it off. You have to call Xfinity. You have to wait for a phone representative who is then going to guide you through the process or send a command to your router/modem to turn off that access point. Now, Comcast says that the reason why they're doing this is because they're trying to build out a Wi-Fi network for all Comcast customers, and they ensure us, they say, cross our heart, hope to die, that there's no way to access the private network from the public network. They also say that, oh, it's not going to affect their speed, but Chibert, let me throw this to you first. We know that cables use a shared node. It's a shared media. So is there any way to guarantee that it's not going to affect your speed if, let's say, your Xfinity guest Wi-Fi hotspot starts getting a lot of traffic?
Oh, sure there is. All you need is the TARDIS brand router. It's bigger on the inside than the outside. Yeah, sure.
Okay, we got the obvious sarcasm there. Jira, let me throw this to you and ask you, this, I mean, it sounds like a PR disaster waiting to happen. More than that, this sounds like a network disaster waiting to happen, right? A bunch of people who are running a guest network on their network not knowing about it.
No, I want to be the lawyer going with the class action suit. That's what I want.
Yeah, unfortunately, I think that's where we're heading. Now, Lou, let me throw this over to you for a bit, because this is really aimed at the home consumer. This is aimed for the customer who's running the cable modems inside neighborhoods and such. What Comcast is doing is from a network side, it's interesting, right? I mean, they know that they got all these points of presence, and they're figuring, well, if we just turn on these Wi-Fi hotspots, suddenly we become one of the largest wireless networks in the country. From that side, can you understand why they want to do this?
Yeah, I mean, companies all the time, they struggle with the whole opt-in, opt-out scenario. I mean, Microsoft does it all the time too. But having the normal opt-in by default allows the kind of like the more widespread adoption without having to kind of force the user to do it. And if you have an opt-out by default, where they actually have to opt in, it sometimes rolls out a lot slower, so you don't get that widespread ability right away. And so I think I kind of see where they were coming from when it says, hey, let's default it on and then make it kind of hard for them to turn it off. And this way, everyone takes advantage of it right away. They get that, they get the ability to be able to hop from hotspot to hotspot and be able to have a seamless connection no matter where you go. But I mean, I think it's too forward thinking. Like you said, a lot of people are going to say, oh, there's going to be some security problems. Plus, they can't guarantee it's not going to slow down my bandwidth. So of course, there's going to be a lot of people pushing back.
Yeah. Now, Chibert, let me ask you this, because there is an enterprise angle here, and that is we've talked about how people like to work from home. We've talked about how there's a lot of productivity that's happening outside of the offices, being at a home or at a branch office. So the question becomes, if this is going to become the norm, if more and more carriers, assuming Xfinity gets to do it, Comcast gets to keep the system, assuming that they start rolling out their own wireless networks in the unregulated Wi-Fi space, what would you, as an administrator, do to your system for those people who may be working from nodes that are, by their very nature, security compromised?
Oh, it's bad juju. Well, no, here, let's actually really put this in perspective for the consumer rather than the enterprise. By having all these extra APs and networks out there, we're going to have significantly higher duty cycle on the existing channels. Keep in mind, 2.4 gigahertz, so B and G and one version of N only has 3 non-overlapping channels, 1, 6, and 11. There's a lot of consumers out there that think they're being clever by going to other ones, but by putting more and more networks out there, and these are going to be at full power, it's going to basically make 2.4 gigahertz nearly useless in different types of neighborhoods. From an enterprise standpoint, that means I've got to be a lot more diligent. It means I've got to throw more people at the problem of policing the rogue access points. I need to go and maybe start getting into doing, say, a MAC address authentication, or I need to make sure that my users are using radius against my Wi-Fi network, and then purposely de-authing my users from the rogue networks. It's a real big problem, and it's going to force a lot of enterprise to spend a heck of a lot more money on their Wi-Fi infrastructure when people start flooding unwelcome networks into my enterprise.
Yeah, and It's Me in the chat room has a good comment. He says, wow, 6 strange cars parked at the end of my driveway using my hotspot. I think there's definitely a couple of things that we're going to have to suss out. Interesting idea, not a bad deployment, but I think it was just probably a ham-handed use of an existing network infrastructure. Let's move on to the next story. And Chibert, I made this story specifically for you. That is that Cisco feeds a patent troll. We get this story also from Ars Technica, talking about how Cisco was sued by the now infamous IP troll Innovatio IP Ventures. Now, Innovatio bought old Broadcom patents and sent more than 13,000 letters asking hotels and coffee shops to pay between $2,300 and $5,000 in licensing fees for their off-the-shelf routers to provide Wi-Fi services. Now, nobody paid them, of course, because these are just crazy letters. So then they started suing. Well, Cisco and Motorola stepped in. They said, wait. These people are using our gear. We're going to be a shield. We're gonna take the lawsuit on our own. Cisco negotiated a deal with them to pay them $2.7 million to give all customers from Cisco immunity from lawsuits. That's down from the $2,300 to $5,000 per business, and even down from the several dollars per device sold that they wanted from Cisco originally. I think it totals up to something like 9.23 cents per device sold by Cisco. It also means that Innovatio didn't get as much from Cisco as they paid out in legal fees. Of course, Cisco themselves spent about $13 million on the legal fees. Motorola Solutions and SonicWall have yet to reach an agreement. Netgear and HP have, they have reached an agreement. Netgear and HP have not. Now, Innovative Wireless Solutions, which is another company, is trying the exact same tactic. Tibert, let me throw this to you. This is the definition of an IP troll, right? This is a non-practicing entity. This is a company that acquired patents solely for the purpose of suing, and they acquired those patents because they were so vague that they could shotgun them at a bunch of different vendors who maybe just would give some money to make it go away.
Okay, so the note on the story says this drives Chibert batshit crazy. That's totally, completely correct. Stop feeding the pigeons. You know, if you feed pigeons, there's more pigeons. If you feed more pigeons and they start coming around, you're going to have pigeon crap all over you. Stop feeding the pigeons. So after that opinion, good for Cisco, good for them for protecting their customers. I like the SonicWall guys, so I'm glad they got in and protected their customers, because if someone tried to sue me, I'm going to go and try and see if I can twist the arm of the Hawaii State Attorney General to go and throw a counter lawsuit and tie them up and make them come to Hawaii, and we're going to charge the crap out of them in Waikiki until they're broke from hotel bills. How's that?
Okay, I'm glad that you don't have any strong feelings. Let me go over to you, Lou. This is something that your company actually has to worry about a lot, right? Because Microsoft gets these little patent suits all the time.
Yeah, there's a thing called SkyDrive.
Oh, right.
So, but yeah,
that.
I mean, all the time this happens, and I think, for me, I feel like Cisco kind of had to do what they did, because otherwise, all these little businesses are going to stop using Cisco products, and so I'm not necessarily going to give them a nice badge of honor, but they did do a good job of kind of regulating what was happening to them, so that was good. But yeah, Microsoft alone definitely always has a bunch of people attacking them every day when it comes to patents and stuff like that. Sure.
Yeah. Now, I want to move on to a supporting story that actually has a big bearing on this story. And that is, even as Cisco was paying one patent troll, feeding the pigeon, as Chibert has mentioned, they're trying to starve another. Now, this other patent troll, you've probably heard about them. It's the Rockstar Consortium. So the Rockstar Consortium was formed to negotiate the licensing of the patents that were acquired by Apple, BlackBerry, Ericsson, Microsoft, and Sony as a non-practicing entity. They bought these patents for about $4.5 billion in June of 2011. They were given to the consortium to say, look, these are the patents that we own. Now go find those who are infringing on the patents. Cisco is one of the first in the batch of lawsuits that were filed in October of 2013. Rockstar went after Samsung, Google, HTC, LG Electronics, Huawei, Pantech, and ZTE. And in the December of 2013, they were countersued. Now, this month, Rockstar went after several companies in the broadband business, including Time Warner, Windstream, Knology, WOW, Cable One, and many others who provide the broadband or make the equipment that allows us to provide broadband. That includes Cisco. Cisco, once again, stepped in and said, we're going to act as a shield. Since we're the ones who made the equipment that they're using in their broadband service, or made the network gear that's being used for this network delivery, we're going to take the brunt. And in this case, they've said, no, we're putting on the armor. They've asked a judge to declare it dead, to give them a declaratory judgment. And they're stepping up to the bat. I'm going to give this to you first, Lou, because I know this is kind of sensitive, because Microsoft is part of the group that bought the Nortel patents. Does this seem right to you? I mean, you've got companies who basically use some extra cash to give patents to a third party that's now using them as a blunt weapon?
So personally, I think, most companies, it doesn't necessarily have to be Microsoft. Anybody who's got a deep pocket, Time Warner, all these companies, they're going to come along. If they're, if they can make a deal and put themselves, in a good position for the future, I think they should do it. But, that goes along with the normal consumer. They're going to kind of sometimes reap the negativity of that deal. So, it depends on really the point of view of what they're doing it for. If they're just doing it to hold on and maybe make some cash later on, probably not a good idea. But if they're doing it to basically move forward and improve products by using these patents, then I think that, if they got the cash, they might as well use it.
Okay. And actually, okay, let's stay on this, because that's an interesting point. Chibert, both of us tend to default to the, oh my gosh, another patent troll, this is ridiculous, I hate this. But at the same time, if a company like Nortel, which actually made gear, made good stuff, made things that really advanced the networking industry, the IT industry, goes out of business, don't they deserve the right to sell off some of their hard-earned IT patents? And if they have that right, shouldn't the person who buys it or the entity that buy it have the right to do with it what they will?
Oh man, I wish you wouldn't shove me into those kind of corners. You know my opinion on patent trolls. I hate it with a passion. I've been victimized by patent trolls when I was with the government, and we ended up having to sic the Attorney General's office on them. Now, having said that, yeah, if I invent something really cool, but I stink at marketing and I don't manage to make any money and I go out of business, I would like to be able to recover at least some of what I invested, some of my sweat equity, and sell that to someone. Now, once I've sold it, do I really have a right to say what they do with it? In the United States, I don't think we do. Maybe in a communist country, maybe. But yeah, I don't think I have a right to say what to do with it once I've sold my intellectual property.
Right. I think one of the big issues here is that when Nortel was still in existence, they licensed their patents under the FRAND agreements. That's the fair, reasonable, and non-discriminatory licensing. The idea is if you have a vital patent that forms the foundation of an industry, you're not allowed to pick and choose who you can license it to, because you're impeding on competition. The problem here is that because Nortel no longer exists, those patents which had previously been licensed under the FRAND principles are no longer restrained by the FRAND principles. Rockstar doesn't make anything, and therefore they don't have to be free, non-discriminatory. Lou, let me throw this back over to you. I'll actually get the last words from you. In a perfect world, what would you like to see change in the IP system? And I'm talking about, because Microsoft, on this case, I think they're on the wrong side, but they've also been the victims of patent trolls in the past. What do you think can be changed in the patent system that might make for an innovative environment that at the same time doesn't shut down the environment, the innovative process once we get a certain distance into the game?
So I've written several patents, and writing patents, sometimes you get yourself into a corner where you potentially write a very general statement that blankets a lot of things. And I think that if we've kind of forced that in the patent system, where we force people to be very specific on their inventions and on their IP, then it makes it for more innovation to happen around that IP. And so I think that might be one way we can kind of fix it. Now, in the same sense, there are ways around that where people then are making very similar things because everything is very particular. But in the same sense, then it kind of prevents these patent trolls from coming along and saying, hey, I bought that patent. You definitely have to pay me for that. So that might be one way of doing it. Of course, there's positive and negatives to every aspect. But I think that would be a better sense than these more general, statements of, hey, I invented a thing that rolls on a ball and you use it with your hand, and that's called a mouse. Who knows what people can invent around that. So,
well, fellas, I would prefer not to have to call this episode "We Got Lou MM Fired." So why don't we move on to the next story in the Enterprise Bite? Does that sound fair? Let's do that.
Sounds fair.
All right. So, Chibert, how about this? It's the end of the swipe and sign. Yeah, that's right. Wow, okay, and DMCA takedown. Now, starting in late 2015, point-of-sale terminals will no longer use the swipe and sign method of authentication. Instead, both MasterCard and Visa have set October 15th or October 2015 as their changeover date to move to chip and PIN. The United States is the last major market to still use the 30-year-old swipe and sign method, and it's no wonder that almost half of the world's credit fraud takes place in our system because it's so easy to be a fraudster. In the chip and PIN system, user information is not contained on a magnetic stripe like you see on the back of your credit cards. I can't simply swipe it, get an imprint, and therefore have all your credit card information. Rather, it's stored encrypted in the chip, which is read by a reader, and that information changes every time it goes out. So you can't just capture the data stream and replay it. It's a much more secure system. Cheever, let me start with you because we just had an episode of This Week in Enterprise Tech where we were talking about this, and we were saying, look, it's going to take for the bigwigs to finally feel the financial pain before they move us off of this 30-year-old system that the rest of the advanced world has abandoned. I guess this means that we're at that point, right?
I think so. People have been arguing, oh, it's going to be too expensive to go and change out all our credit card readers. Bull. I've been traveling a lot, and I purposely go and look at all these credit card validation phones. Those little Zon Juniors are almost completely gone. Those were some of the last bastions of credit card readers that only had the swipe capability. Most of the modern systems, especially the ones that people are buying now, can read chip and PIN. Now, for those of you that are using iPads, Square has had a chip and PIN reader on the drawing board. They just haven't been talking about it. Now, obviously, I don't have firsthand information, but second and third-hand information says they have actually seen prototypes at Square that can read chip and PIN. So get off your ass, credit card companies. I want my rates to go down.
Well, that's the problem. The story is a little bit vague about that. We know that the credit card companies will probably experience a decrease in retail fraud, probably an increase in online fraud. But at the same time, they're not really sure if the savings are going to transfer over to the customers, to us, or to those retail businesses that are using point-of-sale terminals. Lou, let me ask you this. We've talked a lot about this on This Week in Enterprise Tech, where we're trying to discuss whether or not chip and PIN is the system that we're going to want to get here in the United States. We've seen it a lot in Europe. In fact, any American who has traveled overseas has probably had to use some sort of chip and PIN debit card because they won't take our credit cards anymore. With this announcement, what we're seeing from MasterCard and Visa is that they're saying by 2015, they're going to no longer allow retail stations to use the old point-of-sale systems. That means no more swipe and sign. That means no more old terminals. That means that if you will not upgrade your equipment, they're not going to allow you to use their networks to accept credit cards.
I definitely think it's good that MasterCard and Visa are putting these end dates because that kind of forces small businesses to kind of get on the ball and switch out. And then that also means that there is a more movement. It shows in the public that it shows that they're actually taking an initiative to move everybody to a more secure zone. And so that, I think, will help a better adoption rate. Because then if people don't have these readers, then they're not going to be able to read the cards and they're not going to be able to do their business. So I think it's a perfect movement for them to kind of get where they need to be.
Last question to you, Cheebert. What we saw in Europe was that when they went to chip and PIN, most of the fraud moved online because the chip and PIN system is actually pretty dang good. Do you think we're going to see that in the United States? I mean, we have a pretty developed online presence. I think our online retailers know how to protect security. Would we see the same jump in fraud?
I would imagine so. What I do want to say is I want to pat American Express on the back. When they introduced the American Express Blue cards, the first thing they did was they were giving away all American Express card users a USB-based smart card reader. I still have mine. And they were they were even giving away the toolkits so that online retailers could accept the Blue card. And then they were one of the first cards to really take that next step and say, hey, if you use a blue card and you get hit by online fraud, we'll protect you from that. Of course, everybody else jumped on that bandwagon, but American Express Blue was definitely one of the first. So kudos to American Express. Time to bring back the USB smart card readers, bud.
Show title, kudos to American Express. Now, when we come back, I've got a special guest for you. Those in the IT field will know who he is just by the sound of his name. Cricket, cricket, cricket. But till then, let's take a moment to thank the first sponsor of This Week in Enterprise Tech. They're part of our Twiat Riot, and I'm glad to have them back because, well, we always talk about project management. We always talk about managing big projects in the enterprise, keeping your team on the same page, and that's what they do. They, of course, are Atlassian, and their product is Jira. Now, Jira is one of the world's most powerful and customizable issue and project management systems. It easily captures and organizes your workflow so that you can prioritize and take action on what's important while staying up to date with the activity going on around you. You can easily capture, organize, and prioritize your team's issues, tasks, features, and bugs. You give your team a simple, intuitive interface for collaborating with each other in real time, and we know it's all about real time. It's no good to be going back and forth in email or instant message or even in text. You want to be able to sit there in your pane of glass and find out where your team members are and what they're doing. It just helps you perform better. Jira helps you to seamlessly integrate your planning documents, your backlog, your issues, and your code all in one platform. You can set up any business process you can imagine so that your team works the way that they want, and you can define your own issues to track the information that matters most to your team. Stay in the loop with notifications via email, chat, @mentions, or RSS, and monitor streams of activity or self-updating reports and dashboards so that you're always in the know. Jira lets you expand infinitely in any directions with thousands of Jira add-ons, including test management, time tracking, project management, and hundreds of other uses. If your issue involves code, Jira ties everything together from an initial planning document, the files and the chain sets in your code repository, all the way through to development. In other words, from the beginning to the end, you'll have the same interface, the same project management suite. Jira's integration with Git allows teams to follow their code from development all the way through delivery in one system. There are other systems out there that allow you to have project management, but it's separate from your code repository, and trying to get them to sync up can be a pain. Well, Jira gives you everything in one easy pane, one easy place to understand what's going on, what's happening, where your team is working. You can even build onto Jira yourself with the power of Atlassian's REST APIs. Jira is flexible and simple enough for a 5-person startup, but powerful and reliable enough for a 100,000-person enterprise. Jira is used by over 25,000 companies, including 70% of the Fortune 100 and NASA itself. They sit at the heart of Atlassian's offerings for managing your entire application development process from concept to launch. So here's what we want you to do. We want you to try Jira. Go to Atlassian.com/Twiat for more information on Jira. Monthly plans start at $10 a month for up to 10 users. You can try it free for 30 days. Remember, Atlassian.com/Twiat. That's Atlassian.com/Twiat, and select Try It for free. And we thank Atlassian for their support of This Week in Enterprise Tech. Let's get to it. We have in studio a super special guest, Mr. Cricket Liu from Infoblox. Cricket, thank you for coming up here. It's not an easy trip, especially with all this rain.
Oh, actually, it wasn't that bad. I came up a little bit early.
Now, the people who do IT for a living have probably heard your name before. You're a little bit of a phenomenon. You're a little bit of a star. Tell us really quickly, what do you do at Infoblox?
Well, my title at Infoblox is Chief Infrastructure Officer, which is entirely made up. My boss, Robert Thomas, who's the CEO, came up with it. I like the fact that it has chief at the beginning. That's a nice touch. But I do a lot of different stuff. I speak. I'm sort of a liaison to our customer base. I track standards activity. I work with our internal engineering and product management teams. A whole bunch of different things. It's nice. It's a really entertaining, varied job.
Very cool. Now, let me introduce you to our chief Twilight co-host, Mr. Brian Chi. Brian, you've actually worked with Cricket quite a bit, right? I mean, the two of you were on the Interop team way before I came on the scene.
Yeah, Cricket and well, actually, the weird thing was I was starting to come on, and in those days, the NOC team and the ITMs didn't mix as much as they do nowadays. So Cricket, when I first came on board in Vegas 95, Cricket was already kind of, well, not only kind of, he was a celebrity. DNS and Bind was wildly popular. And the first year I was there, Cricket got mobbed by a whole bunch of people doing a book signing at the Interop bookstore. So I heard about him, but I didn't do a whole lot of stuff directly with him until a couple of years later.
Yeah, Cricket, I heard that story that you were bobbed at Interop by a bunch of screaming IT geeks throwing patch cables at you, right? I mean, that's okay. No, let's get serious. So, I understand that you started at HP, right?
Yeah, that's right. I started working at HP actually as a summer student the summer after my sophomore year at Berkeley. And then I worked there the summer after my junior year, and I started full-time after I graduated in 1988.
And was your focus computer science, computer engineering?
Yeah, I have a degree in computer science from Berkeley. For those who are interested and know about this stuff, it's not EECS, it's LNSCS, so Letters and Sciences, which means that the emphasis was more on theory and math and stuff like that.
And so what year did you start working full-time at HP?
That would have been 1988, like a week after I graduated.
So, okay, back in 1988. And when you started working for HP, what was your responsibility? What were your duties?
Well, I think officially it was electronic mail directory strategy. And in 1988, let me tell you, there was nothing happening in electronic mail directory strategy. So there wasn't a lot to do. It was kind of a dull job, frankly.
Yeah. Okay, set the stage, because there are those people who are watching our program who don't remember anything before the year 2000, and they don't know of a world before the internet. Back in 1988, I mean, we had BBSs, we had the beginning of the internet, we had like CompuServe, the well, but no one had the thing that we called the internet. How was it that you moved from working on mail services that no one cared about to DNS?
Well, I'd had some exposure to the ARPANET, which of course was the precursor to the internet and became the backbone, really, of the early internet, because Berkeley was one of the early universities to have a connection there. And, you know, we didn't think anything of it. We just thought it was a faster way to send electronic mail than the old UUCP network, which seemed to take forever, and you had to memorize these enormously long email addresses to send email to your friends. So we used the ARPANET at Cal for, you know, Telnet and FTP and stuff like that. When I got to HP, that was, I think, pretty much the beginning of the HP Internet, which would become for a while the largest private TCP/IP based network. And I was working within the department that managed the HP Internet, but not the group within the department that had any responsibility for it, which was kind of, you know, kind of sad. You know, all the action was happening somewhere else. And then I ended up completely chancing into DNS. I didn't really know anything about DNS. I was living up in San Francisco at the time, and I was carpooling down to Palo Alto, where HP's corporate offices are, with some friends. And one morning before I met my friends for the carpool, I got a call from my friend John's boss, Rick Nordenston, who I later worked for. And Rick said, hey, John's had a family emergency. If you haven't left the house yet, maybe you'd like to go to this class that he was registered for in downtown San Francisco in his place. If nobody goes, we're just going to lose our money. And I said, sure, if that means I don't have to come into work, that's great. And I said, what's the class about, by the way? And he said, oh, it's on DNS. And I said, okay, I don't know anything about that, but sounds interesting. So I went to this class. It was actually taught by Paul Makapetris, who's the father of DNS. And Paul's an excellent teacher. After the first day, I came back with all this DNS stuff rattling around in my head, and John called me up. He said, hey, my father-in-law is doing a lot better. Do you want me to go to the second day of this class? And I said, no, absolutely not. I said, I want to see how this all turns out. So I went back to HP at that point, but you know, it wasn't my job to do DNS. I just happened to know a little bit about it. So it actually required another complete random event to sort of make me responsible for DNS at HP.
And what was that? So some complete random event. So we know now that you learned DNS by accident, a fortuitous accident.
Right.
And once you had all this information rattling around in your head, how did you get the chance to use it?
Well, I spent some time just for the heck of it. I spun up a name server on my Unix workstation in the office, and I started messing around with it just to sort of keep my skills sharp. And about, I would say probably later on the same year, October of 1989, you may remember we had kind of a big earthquake here in the Bay Area, the Loma Prieta earthquake. And I was actually at Game 3 of the World Series when that thing hit, a game I've never seen, actually, because when they rescheduled it, I couldn't go. Whereas everybody else sort of tore home to make sure that their houses hadn't been destroyed and that their loved ones were okay. One of the things that happened at HP, which was really very minor compared to all the other destruction in the Bay Area. One of the minor things that happened was that we lost a data center. We had a data center in Building 26, which is on Deer Creek Road in Palo Alto. And I don't know exactly why, but the data center was in the basement of the building. And the sprinkler main above the data center cracked, and it flooded the entire data center, turned it into basically a swimming pool with a bunch of HP 9000s at the bottom. And one of the machines that was taken out by the flooding was the primary HP.com name server, which is arguably the most important name server at all of HP. And so a friend of mine, David Northrup, and I got together that evening, and we found some extra hardware that we had. I got him into the corporate office's data center, and we rerouted the subnet that the primary had been on from HP Labs into the corporate offices, and we spun up the a replacement, basically, for the primary HP.com name server. Now, all of this was played out against this, I guess, ongoing power struggle between the corporate offices and HP Labs. HP Labs only ran the primary HP.com name server for historical reasons, because they were the first people to figure out how to run a name server. But they'd wanted to give that responsibility to corporate for some time, and corporate had said, no, you do a good job of that. You don't need to give that to us. Why don't you keep doing it? But at this point, the name server had actually physically moved to the corporate offices, and Labs said, your problem now. and corporate said, no, we don't have anybody to run it. And David, who worked for HP Labs, said, Cricket could run that for you. And so
and there you go.
Yeah. That's how it became my job.
Now, Cricket, we've got some people in the chat room. We've got a bright group of people who follow the show in the chat room. We've got user 1586 who sarcastically says, "Oh well, of course, a basement is the best place to put your data center." And of course, we would never do that now, right? We always make sure that it's in an area that's not going to get inundated with water. We're going to make sure that it's got backups and secondary backups, tertiary backups. But this was really a different era of computing. Again, I can't stress this enough. Back in '88, it wasn't a given that your systems were going to be interconnected. A lot of us who were not working at huge enterprises had standalone systems, and those that were interconnected could use any of a series of different technologies to make that happen. Cheebert, do you remember back to the first couple of years of the interop net, when we legitimately had 5 or 6 different types of networks that we could be using, different protocols at the same time?
Yeah, actually, my first show, Vegas 95, we had literally 5 different networks. We had, I think FIDI was our primary. That was a blazing 100 megabits per second back in those days. We had an experimental network, ATM OC3. So that was 155 megabits per second. And various other ones. In fact, the really, really super secret, super experimental system was 100 meg Ethernet. Ooh.
Surely not 100 megs.
But in those days, a lot of things didn't quite work as well as they do now. So we had to have a lot of taps in place so we could go and do troubleshooting. Because interop in those days really was all about vendors plugging into an experimental network just to see if they could work with other vendors. It was a true interoperability event. I kind of missed that, but things do change.
Right. Yeah, Lou, do you remember those times when were you working back then where you could be in a lab and you'd have Token Ring, you'd have Ethernet, which was sort of a young startup. You might have ArcNet, maybe a couple like ATM, all in the same place and all interconnected because you've got different parts of your campus using different networks.
Yeah, I mean, I remember, back in college, we had many different protocols going on all at once. And, labs not necessarily always interconnected, but these protocols, again, connecting themselves and bringing each protocol together and each network together. So nowadays, a lot easier that way.
Yeah. Okay, so I want to get back to you, Cricket. You fell into DNS, and obviously you started using your skill set to benefit HP, and then at some point, you moved over to Infoblox.
Yeah, that's right. It wasn't directly. I was at HP for, I think 10 years all told, if you count 2 summers. And then a friend of mine, Matt Larson, and I basically left at the same time to start a small consulting and training company called Acme Byte and Wire. And we ran that for about 4 years. At the end of the 4 years, we had, I think, 11 out of the Fortune 500, Fortune 100, as a matter of fact, as customers, which isn't bad for what was then a 3-person consulting shop. And we sold the company in summer of 2000 to VeriSign. Actually, technically, we sold it to Network Solutions, and Network Solutions merged with VeriSign on the same day. And so I ended up working for VeriSign for about 12 months. And after that 12 months, I left, kind of did my own thing for a while, joined a very small Icelandic company called Men and Mice for about 18 months, and from Men and Mice went to Infoblox. So I've been at Infoblox now it'll be 11 years next month.
Oh, Infoblox is really known for DNS. I mean, it's one of the things that they do incredibly well. I mean, if you can afford it, you get an Infoblox appliance, you get an Infoblox engineer. Cheebert, back me up on this. At Interop, whenever we had a question about DNS, we would call Wally over, right? We'd have him sit down, or Jeff Horn, call him over, and have them explain to us something about DNS or bind that we're just scratching our heads about.
Oh, yeah. And 9 times out of 10, if they didn't quite know about it, they'd be whipping out a copy of Cricket's book.
How about that? Yeah. That's always what happened. Now, Cricket, I would be remiss if we had you in the studio and we didn't ask you about DNS. Are you willing to go through a little bit of a question and answer about DNS and its successor?
Absolutely.
All right. We're going to get to that in a bit, but first, I want to take some time to thank our second sponsor. You know them, you love them. They're RingCentral. Now, when we built this studio, we decided that we wanted to dog food. We had been telling our audience for the longest time that it's safe to be in the cloud, that you should be in the cloud, that you'd be silly not to put everything you possibly could in the cloud. That's why our document sharing is in the cloud. That's why our scheduling is in the cloud. That's why our email is in the cloud. So when Russell, our IT guy, came to us and told us that we could have a full-featured PBX system without the bulky equipment in the basement and the messy wiring and the person to take care of it, well, it was a no-brainer. We love RingCentral. 0 startup costs, no PBX hardware to install or maintain, and now RingCentral has launched Meetings. So in addition to all that we love about RingCentral, receiving voicemails through email, sending and receiving fax messages from our smartphones, the auto receptionist who greets our callers and announces employees and department extensions, now with Meetings, we can host face-to-face meetings in high definition and share desktop or documents with anyone, anytime, anywhere, on any device. Meeting makes RingCentral the single best solution on the market today. Now, here's what we would like the Twiat Riot to do. We want you to try RingCentral to see if maybe they are the solution that you need to push your business to the next level. RingCentral offers all-inclusive pricing under $25 per month per user. You can start right now with a 30-day risk-free trial, and they have a special offer for my listeners. When you buy 1 desk phone, you get a second phone free, up to 20 phones. So call this number, designated for my listeners, 800-543-9980. That's 800-543-9980. Once again, 800-543-9980. Or you can go to ringcentral.com and use the promo code TWIT. That's ringcentral.com, promo code TWIT. And we thank RingCentral for their support of This Week in Enterprise Tech. Cricket, DNS. It's actually been the topic of a couple of episodes of This Week in Enterprise Tech. First of all, just explain to me how DNS developed into its current iteration.
Well, you know, DNS didn't sort of jump fully formed from Paul Makapetras' head. Paul used some precursor technologies to sort of inform his work on DNS, something called the IAN 116 name server, something called Grapevine, which was a project that came out of Xerox. And that basically you know, led to the use of a hierarchical namespace within DNS, and so on. But I mean, DNS is actually right now not that different from, you know, the way that it looked, gosh, 30 years ago. You know, we've added new record types. We've added some tweaks here and there to carry zone transfers more efficiently, to propagate them more quickly, to dynamically update zone data, that sort of thing. But, you know, I think that DNS today is pretty easily recognizable to somebody who was doing DNS 30 years ago.
Right. And now we know how DNS works. Essentially, it allows us to resolve a name like Cisco.com or Infoblox.com into the IP address, be it IPv4 or IPv6, at which that server actually exists at. And then I can route my traffic to that server and get it back, et cetera, et cetera. That's the underlying technology of the internet. However, one of the things that we've seen more and more, and we've heard about more and more in the past, I'd say 10 years, is the vulnerability of DNS. Everyone always says, well, we're using a system that really wasn't designed for something as massive of the internet. I want to ask you, I'm not asking you to make excuses, but why do you think DNS has so many vulnerabilities?
Well, you know, there are different types of vulnerabilities. There have historically been vulnerabilities in implementations of name servers, for example. The bind name server, which is arguably the most popular name server implementation, has had lots of vulnerabilities over the years because it's been around for a long time and because we find those vulnerabilities a little bit more easily than no offense to Lou, we would in the Microsoft DNS server because it's open source. It's pretty heavily scrutinized by the internet community. And we fix those vulnerabilities when we find them. Unfortunately, fairly recently, a guy you may have heard of, a guy you may have talked about, named Dan Kaminsky, found what are actually systemic vulnerabilities within DNS, so design flaws, if you will, that make things like cache poisoning possible.
Right, yeah. And so, yeah, we know that cache poisoning is basically a how do we call it? A aggressive agent, a distrusted agent, someone out there essentially screaming over and over, I am the server, I am the server, I am the server, and trying to get the traffic for another server delivered to him.
Right,
yeah.
Right.
So what allows for that? I mean, what I'm trying to get at is when DNS, as you said, was being iterated, as it was being slowly developed, not coming out fully formed, did anyone ever think that these vectors of attacks would be used to compromise the integrity of traffic on the internet?
Well, I think that that wasn't a chief worry of Paul's when he was developing it. You know, his design is actually an enormous success if you think about, for example, its scalability. But the internet, or even really the ARPANET back in those days, was a much friendlier, more collegial place. And so that just wasn't a leading concern when he was coming up with the design.
Got it. Okay. Lou, let me go over to you since there seems to have been a shot across the bow here. Microsoft has its own DNS implementation. I have alternately heard it being called very easy, very, very simple to install, very useful, and called the spawn of Satan himself. What is Microsoft's view of DNS?
Yeah, so I'm definitely not going to pretend that I know what Microsoft is thinking with DNS. I'm definitely not a network guy. What I do know is, you know, we're constantly improving things. So secure DNS could be potentially something in the future. So,
yeah. Now, Cheebert, let me go over to you because recently we've started hearing about secure DNS or DNSSEC. This is supposedly the solution, right? This is the thing that's going to fix DNS for us.
Yeah, that's what everybody says, and that's kind of what I believe. Now, I'm going to defend Microsoft a little bit.
Oh, okay, good.
Their DNS implementation actually supported IPv6 before a heck of a lot of other people, And while DNSSEC wasn't implemented, the word I got from the DNS product manager was DNSSEC isn't baked yet. So why should we spend a ton of money implementing something that's not baked? However, he did say, well, you know, we kind of have the same effect because Active Directory, if you're using Active Directory as your primary DNS in your corporation, we can do read-only copies, and Active Directory synchronization is already more secure than DNSSEC. So he didn't quite answer the question, but yeah, Microsoft has actually been doing some really cool things with DNS, and I will pat them on the shoulder for that.
All right, Lou, Cricket Lou, let me go back over to you. What would you say are the top 3 vulnerabilities of DNS? As you see it, the old system, what are the things that the attack vectors you see most often?
Sure. And just before we go to that, I do want to say that Microsoft does support DNSSEC. They've supported it since the Microsoft DNS Server in Windows 2008 R2, I think. And I'm told that the implementation that's in 2012 R2 is actually quite good. I've never run it myself, but you know, we shouldn't. We should be perfectly clear about that. They deserve kudos for that. The big vulnerabilities that we see right now in the world of DNS, there are a few of them. There's the bugaboo of cache poisoning.
Right.
Cache poisoning, when it happens, when it's successful, I think is not widely reported. It's sort of a surgical strike because with cache poisoning, if you're successful, you can inject something into the cache. You can maybe redirect a bunch of users who think they're going to their bank's website to one that looks identical to their bank's website, where they reveal their authentication credentials, and all that stuff gets captured and then reused to siphon money out of accounts later. But then the data times out of the cache, and there's probably no evidence other than the drained bank account that the cache poisoning attack has ever happened.
Right.
When organizations are victims to cache poisoning attacks, I think as often as not, they don't report it unless they're actually required to by some sort of regulatory regime. So I'd say that's one category. Another category that we see an awful lot of nowadays, unfortunately, is DDoS attacks. And DDoS attacks really have sort of twice the relationship to DNS. External authoritative name servers are really, really high-profile targets for DDoS attacks, because if you can take out people's external authoritative name servers, you can effectively knock them off the internet. People can't reach their web server anymore. People can't send them electronic mail anymore. But at the same time, name servers make really, really good amplifiers in DDoS attacks against other folks. So, you can get out of a big authoritative name server that hosts DNSSEC signed zones, you can get amplification of like 100+ times. So you have a few of those on your side, and you can generate, potentially tens or even hundreds of gigabits per second worth of garbage traffic to throw at people.
All right, so those are the ways that people have been attacking the DNS system as it exists right now. So can you explain to us, in terms that we can understand, what is DNSSEC and how does it solve for those problems?
Well, DNSSEC is our abbreviation or our shorthand for the DNS security extensions. This is a set of protocol extensions to DNS that introduce asymmetric cryptography that basically allow us to digitally sign zone data. And once you've digitally signed zone data, recursive name servers, the ones that are actually sending queries and looking things up for people, that are suitably configured and that understand DNSSEC, can then cryptographically validate the signed data. And by cryptographically validating it, they can determine that it's really from the right organization, that really is, for example, the address record of www.infoblox.com as signed by the administrator of infoblox.com, and also that it hasn't been modified since it was signed. So you get authenticity checking and you get integrity checking both. And so that sort of does away with any of this cache poisoning.
Right. DNSSEC would it require me to change out my equipment? Let's say we always use the example of the 10,000-seat enterprise network. Let's say I'm running a 10,000-seat enterprise network. I've got a couple of different branch offices. And do I need to now swap over all my DNS gear in order to make it work with DNSSEC?
Well, it really depends somewhat on what you're running today. If you've kept up and you're running a recent vintage Microsoft DNS server or a recent vintage Bind name server, then it probably has DNSSEC support baked into it already. So there may be no need to actually replace anything, you just have to reconfigure it. You have to configure what we call trust anchors on your recursive name servers, on your internet-facing authoritative name servers. You'd actually have to go to the trouble of digitally signing that data, going through the signing process.
Right, right. As you mentioned, one of the recent shifts in attacks on the internet has been from DDoSing computers or DDoSing servers, because they realize that we're getting much better at defending against those. You know, you drop a couple of boxes with asymmetrical workloads like some F5 big IPs or VIP irons that allow you to request a little bit of work from everyone that requests a bit of data from you, which kind of just cuts off the DDoS attacks. They've shifted from doing that to attacking DNS servers themselves. Question, would this help against a distributed denial of service attack against a DNS server if they were using DNSSEC?
Unfortunately, DNSSEC has sort of the opposite effect. DNSSEC, because of the overhead of carrying these digital signatures in DNS, DNSSEC makes responses a lot larger. You know, most traditional DNS responses are relatively small. Even if you've got multiple A records, for example, in a response, you're talking about a response that's maybe, you know, a couple hundred bytes long, maybe a few hundred bytes long. With DNSSEC, because you're carrying these big digital signatures and sometimes private public keys and things like that, you can have responses that are thousands of bytes long as compared with a query that's probably less than 100 bytes. And that's where you get this gigantic amplification that's so problematic when it's aimed at a particular querier.
Yeah. Let's actually, I want to go around the horn really quickly on that, because that's one of the things that I think we're going to see more often, especially if DNSSEC becomes more of accepted standard, if everyone starts switching over. If, like you said, the payload, the returning payload is a bit larger and therefore requires a bit more work, it seems to me that they're going to have to come up with a different way of protecting the DNS system from a distributed, a DDoS amplification attack. Cheebert, let me propose something that we've actually got in an enterprise byte. I wanted to save for later, but we're going to use it now. Have you ever heard of Doge before? Dogecoin?
Oh, there's a cute dog that I keep hearing with this Doge thing.
Yeah, exactly. So it's a type of cryptocurrency. We've been hearing about it more. I actually showed people how to mine for Dogecoin on an episode of Know How. The way that all of these cryptocurrencies have to work, because they're getting so difficult to mine, is that you need to join a pool, right? You have to be part of a group of users who have all agreed to donate their computer resources to break down these crypto blocks, and then they'll receive the rewards, and the rewards will be divided according to how many resources you put into that pool. A mining pool is really the only way to go. What we've been seeing recently is that as cryptocurrencies get more difficult to mine, be it Bitcoin, Litecoin, or Dogecoin, you're getting attacks against those pools. In fact, Doge House, which is one of the fastest growing ones, just went down, 2 days ago. What happened was they received a series of attacks on February the 5th. Now, they usually get 2 to 3 DDoS attacks a day, reaching about 50 to 75 gigabits per second of traffic. Now, but the attack kept growing, and eventually it reached almost 200 gigabits per second of attack traffic. They moved their operation to the Netherlands and they switched off their DNS entries, but then the attack started going after the DNS servers. It was a DNS amplification attack, and there really was no way to solve for it. I think we're going to see a lot more of that as cryptocurrency becomes more difficult to mine, and if it becomes more valuable, because people are realizing the best way to guarantee your cryptocurrency return is to attack the other people who might be mining the cryptocurrency you're trying to get. Cricket, let me throw this to you. Again, it's kind of the same question. If we are switching over to DNSSEC, what would be a way to defend against that DNS amplification attack, especially as we get more things coming online, like the mining pools that are so heavily dependent on DNS?
Well, there are a few things that you can do. For example, two very, very bright guys, Paul Vixie, who's one of the original founders of the Internet Systems Consortium, the organization that's responsible for developing Bind, and a collaborator of his, Vernon Shriver, came up with a mechanism called RRL, response rate limiting, which basically adds a little bit of intelligence to authoritative name servers to say, look, if you're receiving the same query over and over and over again from the same IP address, at some point you want to throttle it. Most hackers who are trying to use authoritative name servers for amplification send the same queries, because there's one particular query, like a type equals any query for the domain name of the zone that results in the highest amplification. If you see that coming over and over and over again from the same IP address, or even say the same /24, you can throttle it, and that will make that particular authoritative name server much less useful in a DDoS attack against somebody else, a much poorer reflector. And so that's something that ISC is rolling out into mainstream versions of Bind. As that begins to propagate around the internet, we should see that it becomes more difficult to find name servers that you can enlist in a DDoS attack against somebody else.
All right, okay, so that's one way to defend against a DDoS amplification attack. Lou, what about you? Might you have more of a Microsoft-centric way to defend against a DDoS amplification attack against DNS servers?
I mean, one way would put yourself in Azure and let the load balancers handle it. But other ways, to be honest, I'm not really sure what the best way Microsoft recommends in that case.
Okay. Cheever, what about you? So coming from a university environment where, we'll just say things are a bit more loose than you would find on a typical enterprise class corporate network, what kind of attack traffic do you see passing through your campus network?
You name it, we got it. Actually, one of the things that I've been suggesting to various organizations is unified threat management firewalls is definitely not done yet, and having the ability to have a full stream intrusion prevention, dig into the stream and take a look at it, is a pretty useful thing. And the one in the lab actually does a pretty good job of people trying to nail my DNS to the wall. But I will say that the denial of service attacks have rarely taken down the Infoblox clusters that we use at UH. I think we've got 6 machines in our cluster now, and so far all the denial of service attacks have not managed to take them down yet.
Right. Cricket, we've got a question from the chat room. Again, our chat room is pretty, well, they're just bright. From It's Me. He wants to know, well, how do recursive DNS servers get the keys to authenticate the DNS data?
Yeah, that's a really good question. So the way that DNSSEC works is actually pretty similar to the way that DNS itself works. It doesn't require any kind of X509 certificates or anything like that. It's all self-contained within the DNS namespace. But the only thing that a recursive name server needs in order to validate really anything that's signed is the public keys for the root zone. And from there down to any zone within the internet's namespace, any zone that's actually signed, you have what's called a chain of trust. So the private key that corresponds to the public keys for the root zone, the private key is used to sign the public keys of, for example, the top-level domains. So com, net, org, the country code top-level domains, and so on. For an organization like Infoblox, which runs infoblox.com, we have our public key signed by the private key of the com zone, so our parents. So you can basically trace this chain of trust from the root down to any signed zone anywhere in the namespace, as long as there's a continuous chain of trust, that is.
Right. Well, Cricket, we've pretty much reached the end of our hour. I know it goes fast, but is there something, some nugget of wisdom that you'd like to leave with the Twilight Riot, those who are maybe trying to get into DNS the same way that you did all those years ago, running to that seminar made open by a last-minute accident?
Well, the one thing that I'd say about DNS, about internet technology in general, is that it's a fabulous opportunity. It's something that you can learn all about on the internet for free and make yourself valuable to the company that you work for. Things like DNS you can explore online. At Infoblox's website we have videos, we have white papers, but you can also read the original RFCs that describe the way that these protocols work. Lots of other vendors, lots of other organizations make stuff available. So, I'd encourage people to explore what's out there. Of course, I'd love it if they bought a copy of one of my books too, but maybe you don't have the cash for that. There's still a lot of stuff that you can get online.
Well, Cricket, I'd love to have you back on the show when we have some of our grumpy tech pundits on. I think Oliver hates everything about DNS, so maybe we can sit the two of you next to each other. Would you be willing to come back for a future episode?
Oh, absolutely.
All right, all right. Gentlemen, thank you so very, very much. This has not just been a lot of fun, but it's been informative. Let's go around the horn and thank everyone, all my panelists, starting with you, Brian. I know that you're a busy man. I know that you've got things going on in Honolulu, but where can people find out what's going on and where to find you?
Well, I do tweet a decent amount. ADV, you can see it on my bottom third. However, I am starting to post an awful lot on the Honolulu Maker Faire site, both on the Facebook and Google Plus and Twitter. We're throwing out a whole bunch of pictures that I actually shot last year at the Bay Area Maker Faire.
Woohoo.
And then we're going to be interviewing a whole bunch of Honolulu makers and putting their interviews up on the website and Facebook and so forth. So look for a lot of information. It is definitely March 15th at Iolani School in the Sullivan Center. And we've got some really cool things like 3D printers, Raku, and we're going to be teaching soldering.
Go find him. That's Brian Chi. Lou Maresca, again, I think you're trying to take my job, but where can the Twilight Riot find you, and where can they find you on the Twit TV network?
Sure. Twitter.com at LouMM, and check out Coding 101. Some great coding tips on there. Great coding show. And then on the Twit network. And then also crm.dynamics.com. Check that out. That's a lot of the work that we're doing. CRM coming to more devices near you soon.
Fantastic. And Cricket Lou, again, thank you for making your way over to the studio. Could you tell us a little bit about where they could find you? I know that we already know about your book, but where could they see what goes on in the mind of a DNS master?
Maybe from one of the Pauls. But yeah, you can find me on Twitter at CricketOnDNS. I have lots of blog content up on www.infoblox.com as well. We've got lots of videos up on the Infoblox website as well, where I talk about various DNS topics. We've got recorded webinars and all the rest. More than enough to make you sick of looking at me.
No, we could never get sick of looking at you. I mean, come on, you are DNSSEC perfection. I also want to thank you. That's right, you, the person who is watching or listening right now, be it live or on a download. You are what makes this show possible, and I want to give you something. What I want to give you is an easier way to get every episode of This Week in Enterprise Tech in your inbox, in your device, of your gear tech gadget of choice. Just go to our show page at twit.tv/Twiet, and you'll find a little drop-down menu that will give you the options to get the versions that you want into the devices that you have. Do you want it on your iPhone? Sure. You want it on your iPad? Of course. Do you want it on your Android phone or tablet, your PC, your Mac, your Zombie Zune? We make it all possible with one simple click. Also, did you know that we have a YouTube page? That's right. Yeah, if you go to youtube.com/Twiet, you'll find not just all of our episodes, but you'll also find the individual segments that we put into our shows. Stuff My IT Guy Says, The Data Closet, Pro Tip, Pro Tools, all those little bits and pieces that help you to learn the art of the IT masters. Also, why not follow me on Twitter? I mean, if you want to talk to me, this is probably the best way to do it. Go to twitter.com/PadreSJ. That's at PadreSJ. And if you follow me, you'll be able to ask me for future topics of Twiet. You'll be able to ask me questions about the show. And as happens a lot, you'll be able to ask me to be put in contact with the vendors and the personalities that we have on each and every single episode. Also, did you know that we actually do this show live? That's right, live every Monday at noon. Actually, no, I'm sorry, that's wrong. Every Monday at 2:30 p.m. Pacific time. It used to be noon. You can come to live.twit.tv and you'll find our live stream. If you come early, you get to see the pre-show. You get to see all the bloopers, and you get to see the post-show. All the things that don't make it into the finished cut. It's one of those things that we really enjoy about twit.tv. And as long as you're watching live, why not jump into the chat room at irc.twit.tv. You've seen me pull from the chat room every once in a while. I get questions from them all the time. They are some of the brightest engineers, some of the funniest people, and some of the most innovative trolls you'll ever meet. I want to thank everyone here in the Brick House who made this show possible, to Carson, my super producer, to, it's not Jason today. I think I have, is that a hippo at the TD desk?
Oh, hey, Padre. Yeah, I'm not
Brian
usually
Burnett.
here.
Oh, Brian Burnett, I understand that you just started hosting a new show on Twit TV.
Yeah, go figure. It's that show that you also do.
No way. Oh, what was it called?
Know-how.
Know-how.
Twit.tv/Cage.
Twit.tv/Cage. I understand that Know-how is live every Thursday at 1:30 p.m. Oh, sorry, at 12:30 p.m. Pacific time.
That's right. That's right.
Go figure. Well,
Crazy.
You know what? You should really go check out Brian. He's a geek worth adding to your podcatcher.
Yeah, if you want to know how to make that, catch next week's episode.
Yeah, and by the way, that's right. That's a Valentine's gift. If you want to make something blinky for the person that you love, this would be the way to do it. Oh, by the way, that's not Pac-Man. That's Bit Gobbler, correct?
Yeah, who's Pac-Man?
Yeah, there you go. Ladies and gentlemen, that's the end of our show, the Best Dang Enterprise podcast, according to 5 out of 6 Bit Gobblers. I'm Father Robert Ballas reminding you, if you want to know what's going on in the Enterprise, just keep quiet.